And now we are on the last section, linear inequalities in two variables. So let's dive right in with our first example. Graph the solution set to this linear inequality 5x minus 10y greater than 20. So as you can see, this is a linear inequality in two variables, and we have to graph the solution set to this, which means that we have to plot all the points in the plane that satisfy this inequality. So how do we do that? So the strategy here is to modify this inequality and write it in a form that resembles the slope-intercept form of a straight line. So we know that the slope-intercept form of a straight line or a two-variable linear equation is y equal to mx plus b. So what I'll try and do here is rewrite this in this form, y greater than mx plus b or y less than mx plus b. Because this is an inequality, we won't get an equal to sign, we will get an inequality, but we will modify this in a form that resembles the slope-intercept form. So let's do that. First, I will add 10y on both sides. So that will give me 5x greater than 10y plus 20. And now I'll subtract 20 from both sides. So I'll get 5x minus 20 greater than 10y, which I will actually just write the other way around. I'll write this as 10y less than 5x minus 20. And the reason I did this is, remember, I'm trying to get to a form that resembles the slope-intercept form. So 10y less than this, and now let's just divide by 10 on both sides. So I get y less than 5 over 10, which is 1 over 2x minus 20 over 10, which is minus 2. Okay, so y is less than 1 over 2x or half x minus 2, and this form of the inequality, as you can see, somewhat resembles the slope-intercept form because the right side is in the form mx plus b. So for a moment, forget about this inequality and think about what would have happened if you had an equal to sign here. So if you had y equal to 1 over 2x minus 2, how would you plot this line? So we already know this. We have the slope, we have the y-intercept, or we can just plot any 2 points and draw a line through them. So for example, if we take x as 0, y would be negative 2. So that's one possible point on the line. And if we take, let's say, x as 2, y would be negative 1. Okay, so these are 2 possible points on this straight line. So let's plot them. 0 comma negative 2 is here, and 2 comma negative 1 is here. And now let's just draw a line. So this is our straight line, and what we really have to plot though is y less than half x minus 2. So while this line is the plot of y equal to half x minus 2, we want y less than half x minus 2. So that simply means that if you take any point on this line, the y coordinate will be equal to half x minus 2. But if you take any point below this line, so if you take this point over here, for this point the y coordinate will be less than half x minus 2. And that will be true for all points that lie below this line. So that's the key idea here. Once you have plotted this boundary line, which is y equal to half x minus 2, you take all the points below that line, and that is the solution set of the inequality. So all these points below this line basically form what we call a half plane, because the plane is being divided into 2 parts by this boundary line, and the points on the boundary line itself won't form the solution set because we have a less than sign here, but all points below the boundary line will be the solution set of this inequality. So that's how you graph the solution set to inequalities in two variables. You plot the boundary line first, and then you take the appropriate half plane as the solution set. Now here's a nice SAT sampler on this idea. Which of the following graphs represents the solution set of 7x minus 12y greater than equal to negative 5? So once again, we will first write that inequality in a form that resembles the slope-intercept form, which means we'll write it either as y greater than or less than mx plus b. We'll try and write it in this form. Okay, so how do we do that? first let me add 12y on both sides perhaps. So I'll get 7x greater than equal to 12y minus 5. And now let me add 5 on both sides. So I get 7x plus 5 greater than equal to 12y, which I can actually write the other way around by saying 12y less than equal to 7x plus 5. And the reason I'm doing this is simply because I want to get to a form like this. And then if I divide by 12 on both sides, I get y less than equal to 7 over 12x plus 5 over 12. All right. So I have rewritten my original inequality, in a form that resembles the slope-intercept form. So this, if we had an equal to sign here, y equal to 7 over 12x plus 5 over 12, that would be the boundary line, and points on the boundary line would also be part of the solution set because we have an equal to sign here. So let's look at which of these 4 options correspond to the boundary line y equal to 7 over 12x plus 5 over 12. So the line should have a positive slope, which means options B and C are ruled out automatically because the boundary lines there have negative slope. And then we also note that we have y less than equal to, so the half plane would be the plane below the boundary line. So in this option, you have this boundary line and the half plane is above it. So you can also eliminate this. And here you can see that the shaded half plane is below the boundary line. So this seems to be the correct option. And in fact, you can verify that the y-intercept of the boundary line should be 5 by 12, which seems to be the case over here. And once again, reiterating that points on the boundary line will also be part of the solution set because we have an equal to sign here. Whereas in the previous case, this boundary line that I drew here, points on this boundary line would not be part of the solution set because you only have a greater than, or you have a less than sign in that inequality. Okay, so in this case, therefore, the correct answer is option D. Okay, the next theme in this section is systems of linear inequalities in 2 variables. So what does a system of linear inequalities really mean? So here's an example. We have 2 inequalities here in 2 variables, and taken together, we will refer to this as a system of linear inequalities. And what is the solution set of this system? Well, you just find the solution set of each of these inequalities, which would be a half plane, and then you take the intersection of the 2 half planes or the common region that lies in both the half planes, and that would be the solution set of the system of linear inequalities. So here's a problem based on this idea. Which of the following ordered pairs satisfies both of the given inequalities or the system of inequalities? So how would we do this? Well, we could just plot the half planes which are the solutions to these 2 inequalities that we already know how to do that, and then we look at the common region of the 2 half planes and figure out which of the 4 points lies in both the half planes or the intersection of the 2 half planes. So that's how we do problems of this kind. So in this case, it's very easy to do such problems using Desmos. So we can simply plug in these 2 inequalities into Desmos. Desmos will give us 2 half planes, and we can just look at the intersection to find the solution set of the system. So let me show you this example on Desmos. So here's the plot of the 2 inequalities. So this red dotted line corresponds to the first inequality, x less than 4 minus 2y, and the half plane below it, the shaded area, as you can see, is the solution set of the first inequality, and the boundary line is dotted because we have a strict inequality there. The second boundary line here corresponds to the second inequality, which is y less than equal to minus 2x plus 1, and the half plane below this, which is, you can see it here towards the left of this line, is the solution set of the second inequality. So the common region here, which is really the intersection of the 2 half planes, which will actually be this region, will be the solution set of the system, because this region or any point in this region would satisfy both the inequalities. So all we need to do is to find out which of the 4 given points lies in this intersection, or this lies in both the half planes. So point A is -1, 3, does not lie does not satisfy the first inequality because it lies above the boundary line, the first boundary line. Point B is 1, 1, which lies in the first half plane but not in the second one. Point D is 4, 4, which lies all the way over here in either half plane. But point C, which is 2, -3, which is this point over here, it lies in the first half plane below this line, but it also lies on the boundary line of the second half plane, and that works for us because the second inequality is actually has an equal to sign. So therefore, among the 4 given options, the point 2, -3 lies in both the half planes, and therefore this is the only point that satisfies both the inequalities or the system of inequalities. Now here's our next SAT sampler. Which of the following system of inequalities is represented in the graph below? So look at this graph here. We have 2 half planes corresponding to 2 inequalities, and we have to find out which pair this corresponds to. Okay, so what we need to do here is find out the equations of these 2 lines, and from there find out which inequalities are correct. So let's take this first line over here, this blue line. So let's write it in the slope intercept form. So we can see that its y-intercept is 2, so it will be of the form something into x plus, so we have to find m, the slope, plus the y-intercept is 2, so let me write 2 here. And how do we find the slope? So let's see, so I could use perhaps this point and this point. So for a run of 3, the rise is 1. Okay, so the slope should be 1 over 3. So y is 1 over 3 x plus 2. So that's the equation of this line. But then the shaded half plane is the one below this line, and therefore this region represents the inequality y less than 1 over 3 x plus 2, but we'll also have an equal to sign here because the boundary line itself is completely solid. So all points on the boundary line are also solutions to the inequality. So that's our first inequality, y less than equal to 1 over 3 x plus 2. Let's see where this figures. So it comes over here and also over here. So the first 2 options can actually be ruled out with this partial answer. Now let's find this equation of the second line. So it passes through this y-intercept is 5. So that's great. So we know that the y-intercept is 5. And then what's the slope? So let's see. So I'm going to use perhaps again this point and this point. So for a run of 3, the rise is 4. Yeah, so the slope would be 4 over 3. So 4 over 3 x plus 5. And now the shaded half plane is the half plane above this line. So this would correspond to y greater than 4 over 3 x plus 5. And also because this boundary line is dotted, I will not put an equal to sign over here. So this is my second inequality, y greater than 4 over 3 x plus 5, which actually figures over here, and therefore option D is the correct answer. Our next SAT sampler says if the system of inequalities y less than equal to -1 over 2x plus 4 and y less than 3x is graphed on the coordinate plane, which of the quadrants contains no solutions to the system? So what does this problem really mean? Well, for each of these inequalities, we would get a half plane as our solution, and then the intersection of the 2 half planes would be the solution for the system. And all we need to do is find out which quadrant has no point in that common region. So we can actually do this problem fairly simply using Desmos. We just plot these 2 inequalities, find the solution set, and then look at which quadrant has no point in that solution set. So let's do that now. So here are the 2 half planes graphed on Desmos. So this first boundary line corresponds to the inequality y less than equal to -1 over 2x plus 4, and we have the half plane below it as the solution set. and then this second boundary line here corresponds to the inequality y less than 3x, and then the half plane below it is shaded, and then points on the boundary line itself are excluded because the second inequality is a strict inequality. And now the common region will be this common area that is common to both the half planes. So which quadrant has no point in this common region? Well, quadrant 1 clearly has points in this region, quadrant 4 has points in this region, quadrant 3 also has points in the common region, but quadrant 2 has no points in the common region. So the answer to our problem is B, quadrant 2. The last theme in this section is modeling real world situations using linear inequalities in two variables. Let's see our first SAT sampler on this theme. A landscaping company is planning to purchase supplies for a project. To stay within their budget, they need to buy G bags of gravel at $18.75 each and S shrubs at $13.25 each. If the total cost of the purchase must be less than $139, so less than means we now have an inequality here, $139, which inequality represents the company's budget constraints? So G bags of gravel at $18.75 each means that the cost of the gravel bags will be 18.75 times G, and then S shrubs at $13.25 each would incur a cost of 13.25 times S. So the total cost will be this plus this, and this should be less than 139. So that's it. Let's see which inequality this is. 18.75G plus 13.25S less than 139. So option C is our answer. You might mistakenly pick option B, but observe that this has an equal to sign as well, which we don't want, because we want the total cost to be less than, strictly less than $139. So option C is the correct answer. Now here's the last SAT sampler on this theme. A farmer is planning to sow wheat and barley in his fields. The farmer wants to plant at most 300 kilograms of grains and no more than 4 times as much barley as wheat. So this wording here seems a bit confusing, a bit convoluted, but don't worry, we'll break this down step by step. Bags of wheat and barley contain 25 kilograms and 20 kilograms of the grain respectively. If W and B represent the number of bags of wheat and barley respectively, which of these inequalities represents this scenario? So we've been given two pieces of information that correspond to two inequalities, and we have to find those two inequalities. So let's do that. So we have W bags of wheat, and each bag has 25 kilograms of wheat. So the total weight of the W bags of wheat will be 25 W. So this will be the total weight of wheat in the W bags. Similarly, we have B bags of barley and 20 kgs, 20 kilograms of barley per bag. So the total weight of the barley will be 20 into 20 times B. So the total weight of the grains will be 25W plus 20B, and we want this to be at most 300 kilograms, which means that this should be less than or equal to 300. So that's our first inequality, and we can see that the first two options have a greater than equal to sign here, so we can directly rule these two options out. Now we will use the second piece of information which says no more than 4 times as much barley as wheat. Now if you pause for a minute and think about this carefully, no more than 4 times as much barley as wheat, this really means that the amount of barley, which is 20B, should be no more than 4 times the amount of wheat. So the amount of wheat is 25W. So 4 times the amount of wheat will be 4 times 25W. So this is 4 times the amount of wheat, and the amount of barley should be no more than this. So the amount of barley, which is 20B, should be less than or equal to the amount of wheat or the weight of wheat. So 4 times 25W is 100W, should be greater than or equal to 20b. And now if you divide both sides by 20, you get 5w on the right side, on the left side should be greater than equal to b. So this is our second inequality, and let's see. So this is here over here in option D. So because in option C we have a less than equal to sign, but we want a greater than equal to sign here. So 5w should be greater than equal to b, and therefore option D is the correct answer.